Hello students, myself Santosh Tamboli. Today we will see stack operations. So before we'll see operations performed on the stack, let's see what is stack. Stack is nothing but a linear data structure. Why it is called as a linear data structure? Because the organization of data in stack in linear fashion, or we can say that in sequential manner. Now let's take the example of this stack. So this is nothing but the stack, and let us consider these are the slots where we can store the data: 10, 20 and 30, and these are the indices 0, 1 and 2. So there is a one most important concept in stack which is called as top of the stack, which is initialized as -1. So whenever toss value is -1, we can say that there are no elements onto the stack. That means stack becomes empty. And whenever we need to push data onto the stack, this toss value will be incremented by 1. So let's say if I want to enter this 10, then my toss becomes 0. 20, then toss becomes 1, and finally my data 30 I push onto the stack, my final value of toss becomes 2. The most important thing in this stack, the last element is 30, which is removed first. We can say that pop first. That means the stack follows the policy as LIFO, last in, first out. The data which is pushed last, that is this 30, will be removed first, which is called as LIFO policy. Now let's see the operations performed on the stack. There are two operations, push and pop. Push operation is used to insert data onto the stack, and pop operation is used to remove the data from the stack. Let's see the example of push and pop operations. This is my stack. So these are the slots, indices 0, 1 and 2. Initially there are no elements onto this stack, that means stack becomes empty because my toss value as -1. Now let us take push operation, push s comma 10. So this s is nothing but the stack structure variable, and this 10 is nothing but the data that need to be pushed onto the stack. 0, 1 and 2. Now since toss value is -1, I need to increment the toss value by 1 so that it becomes 0, and then 10 value will be inserted onto the stack. Let us insert another element, push s comma 20. These are the three slots, 0, 1 and 2. 10, my toss value is 0, now it becomes 1, and 20 get pushed onto the stack. Let us take one more example, push s comma 30. 10, 20, indices 0, 1 and 2. My toss value is 1, now it becomes 2, and my 30 get inserted here. Now let us consider the size of this stack as 3. That means maximum I can insert 3 elements onto the stack. So if I insert 40 value, since the value of this toss is 2, That means three elements are already inserted. I will get message as stack full. So what is the full condition of this stack? So whenever your toss value is size minus 1, then I should get the message as stack becomes full. So this is nothing but the push operation. Now let us say pop operation. So in this push operation we need to pass the two parameters, that means structure variable of stack and the data need to be pushed onto the stack. But in pop operation, we don't pass this data that need to be removed from the stack, because data removed always from the top. So we need to pass the structure variable s. So as you can see on the last slide, the top element is 30, which will be popped here. So 10, 20 and 30, indices 0, 1 and 2. Now my 30 value get popped here and my toss gets decremented by 1. So my toss value is now 1. Let us pop element. Now stack contains two elements, 10 and 20, 0, 1 and 2. Now the top element is 20, which is popped. Toss value is minus 1. Now the toss value becomes 0. Let's pop another element. Now stack contains only one element, that is 10. This 10 value will get popped here. Toss value is 0. Now my toss value becomes minus 1. That means it is decremented by 1. If I want to pop one more element, I need to get the message as stack empty. Now why stack empty? Because all these elements are removed from the stack and there are no elements present onto this stack. So what will be the condition for stack empty? So whenever my toss value as minus 1, my stack becomes empty. So the full condition for the stack is whenever toss value is size minus 1, and empty condition for the stack is toss equal to minus 1. So I hope students you understood these operations on stack. Thank you very much.